Well, yeah, good afternoon. I am Daniele, and I would like to talk about my work on intervisible experiments that I conducted virtually within a reconstructed Qatari pearling village. But before starting, I would like to give you a short background on what I specialize in, which is digital archaeology. This subfield of archaeology aims to improve archaeological practice by using digital software and it tries to identify which new technologies can be adopted by archaeologists. I am specifically interested in researching 3D modeling and reconstruction as an archaeological tool. Digital approaches such as 3D reconstructive modeling may overlap with the field of experimental archaeology. Basically, what I mean is that by reconstructing an archaeological site in a virtual environment with 3D software, it is possible to use it as an experimental environment to test specific hypotheses. 3D modeling right now is mostly used in archaeology as just an alternative form of site visualization, but I would argue that this technique fulfills its full potential when a reconstruction of an archaeological environment is used to generate new data, and therefore it can reveal aspects of an archaeological site that were previously unachievable. Here are some examples of what I mean. These are images of 3D modeled sites from some of my favorite research studies which deal with modeling software. These models were then used to create generate new information. On the left, you can see the results of acoustics experiments exploring sound propagation in reconstructed Kopan's main civic and ceremonial complex. In the middle, 3D modeling can also help import reconstructions into software that can confirm the winter solstice alignment at the Gigantia's entrance in Malta. And 3D models taken from laser scanning in the Ardalis caves can be used to experiment how their lighting would have looked like without having to access the real spaces and risk damaging cave art. So for the purpose of this specific project, I focused mainly on 3D modeling to investigate aspects of intervisibility. To be precise, the reconstruction project of the village of Fuwayrit focuses on exploring intervisibility within a typical village of pearl fishers on the coast of the Arabian Gulf. The archaeological site of Al Fuwayrit is comprised of various buildings, most of which were the residences of these pearl fishers settled since the 1800s. This was one of the sites that was focused on by the Origins of Doha project. Fuwayrit is an important landmark for future generations in the Arabian Gulf, since these types of settlements represent a way of living in this area of the world that has now been discarded since the oil industry took over in the 20th century. It used to be located right on the coast of northeast Qatar, but with changes of the coastline, it is now separated from the sea by a lagoon. If Al Fuwayrit is supposed to be a physical expression of a well-defined community of pearl fishers, then I assume that this would reflect in the built structure of the village. If I could build in 3 dimensions a digital reconstruction of a typical Qatari pearling village, we would be able to conduct analysis to assess how the inhabitants would perceive the built environment. So I used the AutoCAD drawings of the site's foundations, combined with information from the excavation reports and other references of Arabian architecture, to rebuild Fuwayrit using the 3D computer graphics software 3ds Max. And these models were then exported into the 3D version of ArcGIS for further analysis. This specific study has had to have a slightly different approach from the other 3 studies that I mentioned at the beginning of this presentation, because they were all undertaken on models that were taken either from laser scanning or using 3D modeling software to rebuild slightly incomplete buildings. However, is it possible to rebuild in 3D a set of buildings that are barely standing and their foundations are the only things that are surviving? Well, the answer was yes, but I needed to deal with an issue. So different assets of a reconstructed site have different levels of uncertainty. For example, I experienced a higher level of uncertainty while reconstructing the buildings vertically in height, since the only tangible remains were foundations. This is why I had to plan how to accurately show my decisions. So I used the extended matrix technique, which basically records your reconstruction process and represents it under a specific set of notions. With this approach, you end up with something similar to a Harris matrix, but instead of a tangible context, it represents virtual pieces of the reconstructive process. And this is my complete extended matrix for the site of Fuwayrit. You can see I chose to base my building heights here on these two documents down here, which told me the average human height of the time and the average building height from standing building recordings from similar sites. Unfortunately, it's a bit too complicated to explain right now, but if you want to know more, you can ask me afterwards. And this is the visual representation of the final reconstruction using the extended matrix color coding. Stratigraphic units whose properties had to be fully inferred by documents are in green, and stratigraphic units based partially on tangible evidence are in light blue. At this point, the experimental process could begin. I imported the virtual environment into the three-dimensional GIS software, ArcGIS. To undertake intervisibility analysis, I had to create a number of observer points distributed using stratified random sampling. These would represent potential locations from which an observer or a person would interact with the environment. Then all combinations of lines connecting these locations were generated. These would represent lines of sight, and potentially I could detect straight lines of sight with unobstructed vision. Although I conducted several intervisibility experiments, I would like to focus on sharing one of my most interesting results, which comes from the lines of sight connecting an observer from the mosque's minaret and observer points around the town. So an observer would be able to likely see the mosque's minaret from the courtyards of Fuwayrit's buildings rather than from the alleyways. This is apparent due to the extremely low number of unobstructed lines of sight which connected the public streets with the minaret observer point. But a stark difference between public and private spaces was not observed. In fact, although many courtyards would contain areas with a better chance to see the minaret than the alleyways, there were not enough of them to state that most private spaces would have been clearly visible from the minaret. Also, every single area south from building B18 was guaranteed to have no mutual visibility whatsoever with the mosque's minaret. And sorry, I jumped the gun and went to the next slide. Some hypotheses have been considered to explain such a pattern. Fuwayrit's mosque could be an example of mosques which are rectangular in plan and do not possess a minaret. Several of these mosques may subsist from early designs and were retained in smaller isolated communities. Another possibility could be that it was not necessary for Fuwayrit's minaret to be seen from everywhere at all costs if the majority of people attending were locals. Perhaps the minaret's visual properties were not supposed to matter, and the acoustics of the call for prayer performed on top of the minaret was considered to be more important. One last reason could be also that the southern part of Fuwayrit, suggested by the less closely packed architecture, was made up of buildings that were constructed during a later stage of the town's occupation as it expanded. So the south area, which resulted poorly intervisible with the minaret, may not have been contemporary with the construction and use of the mosque. And in conclusion, I wanted to finish with stating how important 3D archaeological modeling can be in reconstructing the past in ways that would be difficult through traditional archaeological techniques. Rebuilding Fuwayrit allowed me to try different hypotheses for reconstruction without incurring into the costs involved in a physical reconstruction. Plus, new potential information about the site was able to be inferred. Thank you very much.